What's up, guys? Synthetic Division here. So today's video is going to be kind of a cool one. So if you remember right, if you watch my short, my NerdQAxe Hydro tanked. This is the original 5.1 model with the barrel jack. Unfortunately, the AIO died. Previous to that, I had to get a repair done on the V-Rig. So this one's been through the ringer as far as it goes. So we are going to air cool it. I'm going to just break it down for you what we're going to do. And then on top of that, we are going to do a thermal paste showdown. Now, I have some PTM 7950 from Honeywell. I have some Thermal Grizzly Kryonaut. We have Arctic MX6 and MX7. And then, of course, a whole pile of Thermalright, because this is what comes with every Thermalright cooler. Our bench test is going to be this Thermalright cooler. This came off of the revision 7 NerdQAxe. We are going to use this one for our new cooler. We also are going to have a V-Reg cooler set up right here with a little bracket that I've 3D printed, and it'll put the fan right there. Obviously, our screen's right here. We are going to be testing on this Meanwell 350 watt power supply. You might notice it has an XT60 connector. I like to use this little adapter that goes XT60 to barrel jack. I'll leave a link for these on Amazon. They're great. We'll also be adding some heat sinks, and we will be adding them here on the inductor coils and then right here on the back of the board. Now remember, with the NerdQAxe series, guys, at least with all the ones up until the new Rev 7, the ASIC temp sensor is right here, and the voltage regulator temp sensor is right there. U37 and U38. So we're not trying to trick those, we're actually trying to cool them. You can trick those sensors. So that's what we have here. We have our heat sinks, we have a fan splitter if we need it, and the icing on the top, let me move some of this stuff aside here, is this. So this is the new NerdQAxe Launchpad kit from AvoidBit. This one, he said he was going to send me a sample, but what he didn't tell me and kind of made me gush was he customized it for me. It's got little spinner Bitcoin logos on the side, kind of cool. Does have a fan on the back, a 90 mil, and comes with the 90 mil fan shroud cover for the front. This is pretty awesome. Big thank you to AvoidBit for sending this to me. You surprised me, bud. I didn't realize you were going to customize it with my name on it. So thank you very much. We're going to put it to work today. So I'm going to take this over to the bench. We're going to get this put together, and then we will set it up right here. It is currently 75 degrees in this room. I have it stabilized there. And we are going to test Thermalright, since that's the stuff that comes with these coolers first. Now, this is going to be somewhat of a longer video, but not too long, hopefully. And so I'm going to be skipping through as far as the reassembly process goes, mainly because if you've watched my other videos, you know I have plenty of videos on how to tear down NerdQAxes, BitAxes, OctAxes, you name it. We tear it down here every time. So I'll skip through a lot of this, but I want to get to the point of the thermals and any anomalies that I see with it, okay? The hardest part is going to be the PTM 7950. That stuff is a royal pain to put on. But we'll get to that. Let's get this over to the bench. Let's get this reassembled, and then we'll test it. So hang on just a second, guys. Okay, guys, so we're here at the bench. I've got the heatsink prepped. I was just cleaning it off with alcohol, so that's good to go. No contaminants on there. And we should be ready to rock and roll as far as installing that. Now, the first thing we're going to do is go ahead and get some heat sinks placed on here on these inductor coils, because it does help reduce any temperature to the V-Regs, because obviously these are very sensitive. This one, when it died, didn't actually show me that it was overheating. It just kind of kicked the bucket. So we're just going to place those here like so. We are going to get as much extra cooling as we can on this, because I don't want to have to send it off for another repair. In fact, if it dies, I probably won't send it off for repair, because it's a little bit older of a miner and probably not worth it. I did it for educational purposes for the channel, and it was a good educational. So I think on here we honestly only need 2. We will not need 3, so we'll set that one over there. We're just trying to cover. You can kind of see the traces on the back of the board here, right here. That's what we're trying to cover. Okay, we're not trying to cover that sensor either. That sensor, we're trying not to trick the sensor, but a back fan will literally trick the sensor anyway, so kind of a catch-22 when it comes to that. The back fan does trick the sensor, guys. I don't know if you know that, but it does. So we're just going to put a couple of heat sinks here to help reduce heat to the VREGs. Since we've already had to have one fixed, we don't want to have to do that again. So let's position that one a little better and position that one a little better. And there we go. We've got our VREGs. Now we will install the heatsink. So our first thermal paste that we're going to use is the Thermalright stuff, because this is what comes with all these coolers when you buy them, even with the copper ones. So we're not going to be too shy here, guys. We want enough for coverage, okay? Hopefully there's enough in the tubes. If not, I have plenty of tubes, that's for sure. Because about every one of these coolers I've bought came with some. Okay. Now I did have to scrounge up some new screws, but it was pretty straightforward. I didn't need to worry about that too much. Now to put this on first, you need to put it on without the fan to get it onto the new stand, okay? So just keep that in mind when you're going to put this together. Don't use the stand. Now we're going to check to see if these screws are going to be long enough, because I do have a concern about that. Again, I'm using leftovers of what I had, so kind of the way it goes. We're just going to, and these are non-magnetic screws, so I'm just going to tilt it a little bit. See if that works. Sometimes it's easier to get down and kind of look through the side here, like I am right now. Take my squints off, obviously. We will do that. And we are not trying to bow the board, guys, okay? Keep that in mind. Do not try to bow the board. If the screws are too tight, they will bow the board. And we don't want to bow the board, okay? If you need longer screws, which I think I might actually, get longer screws. It's not a big deal. These are non-magnetic, so kind of pain in the butt. Okay, that should do the trick. We'll use these slightly longer screws to help. And this is pretty much the cooler it's going to get. We'll make sure that we are okay there. Looks like we're crashing into the cooler slightly. So we might have to do some washering here. It's okay. I was prepared for this if I had to. So we'll just take one of these plastic washers we have right here and see if that does the trick. Yeah, that works great. Okay, so now we know we'll need to use those plastic washers that I have hanging out there. Again, we're trying to prevent from bowing the board, guys. Okay, so we'll get these put on. I kind of figured I was gonna need some sort of washer setup because of, just because I don't really have the correct length screws. And crazy enough, the screws that come with the kit, like the copper kit, don't fit this. Found that interesting. But that's okay. Not a big one. You make do with what you got, right? And all I got is a bunch of junk laying around, so just harvesting screws from everything. Okay, so now once we have this where we think it's going to be good, we will tighten the screws until they're equal all the way around. So that way we're not screwing up the board or bowing it or causing a flex in the board like right here. This one is probably a little too tight. We don't want the board flexing. And you'll see why I said to take the fan off here shortly. Okay, so there we go. We've got our heatsink installed. Now we need to take this. This is our AvoidBit stand. This is the Launchpad, which is fantastic product, by the way. I'll show you a little bit of details about this thing real quick, and then we'll go to thermals. So this bolts onto the back. This gives you the Launchpad, which is the heating or the cooling fan right here on the back, hitting the V-regs nice. If you take this off, there is DIN rail tracks so that you could set this in a DIN rail track if you have the bit track system like I do. Now I plan to use the stand because, come on, this thing's awesome looking for one. So that's why. But we need to get it onto this right here. So the nice thing about AvoidBit stands is the board sits flush with it. Okay, that is probably one of the best parts. So we'll take the screws that it came with. Now he does include 6 screws for it because obviously they use 6 corners there. And they're nice machine screws, and there is nut certs built into the board, which is fantastic. Now we won't be using these 2. We will only be using the 4 outside, and I'll show you why here shortly. We will just be installing it into this first. Again, don't crank these down, guys. You're not trying to kill the board, okay? You're just trying to get it in there. Okay, so we've got that. Now we need to install our V-Reg cooler, and it will actually install like this. So when you go to put that fan on, you're going to need to position it downward a little bit, okay? Not a big deal. Let's see if these screws are long enough. If they're long enough, that'd be super cool. Our front V-Reg cooler. And of course I send a screw flying to the floor. So hang on just a second, guys. Okay, guys, so we had to use a little nut and a longer screw, and that is fine. Our V-Reg cooler is attached now. Okay, our front V-Reg cooler. Now, I thought I was going to need a splitter, but I probably won't because this already has one in it. That's pretty awesome. Okay, so that's pretty cool. We're good there. Now, we can put our screen on because we're in good shape there. Make sure we got the pins lined up. I like to push from the ends and not the middle. And then the next part, we'll be putting our front fan on. And I'm going to orientate where all my wires are going to be out this side, okay? So do that. And like I said, this is why you do it beforehand, because you're going to have to position this fan a little bit differently than you would normally, okay? So we'll get our little brackets put together here. We'll get one side started, and on this particular one, these actually go on the top of the fan and not in the on the bottom section. So we'll just go ahead and snap that in. That one snap down there. You want to leave these spaced a little bit apart because if you don't, you may create a vibration noise. So just keep them spaced apart. You don't need to have them stacked on top of each other too much. So we'll put our right there and right there. Now we have our front fans. We have a rear fan. We'll put this in the stand here, and we will get it going. So I am going to go ahead and get the fans hooked up. Just like so. We'll just take this cable off for now. For the test, we'll just leave this out. We'll worry about wiring and resetting it, everything when that time comes. So we'll just do this. Now with the new version of the Nerd OS, you can synchronize your headers however you would like, whether you want to link them or you don't. It's up to you, but I will for now just do this, and then maybe we'll look into linking them and how or unlink them and run VREG hotter or faster than regular fans. You never know, might be good. But for now, I just do this. So maybe if I can get that fan connector on. Okay, so fan connectors are on. We'll leave these off the side. let's move this over to the bench. Let's plug it in and let's see how it's doing. Hang on just a second, guys. Okay, guys, so we're here at the bench. It's obviously working. So to do this kind of how I'm thinking here, the only way to really truly test the thermal paste is just to set these fans at 100% and let it rock and roll. So all fans are set at 100%, back, front, and this top one. Um, and it looks like we've got it set. Let me go to the settings real quick and I'll show you our clock speeds just so you have our baseline, okay? So our baseline frequency is 600, core voltage 1200. Fan controller is set to 100% across the board. They are linked, so I'll show you that real quick if you can see it. That's where we are at. Now, from now on, I will be using Hashwatcher simply because it's a little bit cleaner on the screen. But there we go. We are set. I'm going to let this run for an hour, and then we will switch pastes. Now, I might have to cut these, and I'm not going to show you the breakdown every time, but I will show an insert of me just showing you putting the paste on and then bring it back over to the bench. It would be too long of a video if I just reassembled and disassembled this thing every time. But I'll show you it, a quick blurb of it completely pulled apart, and then back to here on the bench with the thermals. So hang on a second, guys. We'll be right back, and then I'll report those thermals and we'll take it over to the bench. So hang on just a second. Okay, real quick, just figured out we lost the audio. Sorry about that, guys, but we've got it applied. We're going to go ahead and get going with it. This is the thermal Grizzly test. One of these little tubes is about enough to cover one NerdQAxe++. So, all right. Anyways, pause the video. We'll be back to the bench to show the thermals. Okay, guys, so this one's been running for 56 minutes. I'm going to call that an hour. And to be honest, not much has changed. 50 and 38. Now, what I'm kind of thinking here might be somewhat of an issue is we might be limited by our cooler. But that's neither here nor now. This is the cooler we have. So I'm going to go ahead, move it back over to the bench, tear it down again, and get, I guess we'll just go with MX7. We'll see how that does. Anyways, I'll pause the video, and then we'll be right back. Okay, guys, so we just finished applying the MX7. I'm going to set it up on the bench, let it run for an hour, and we'll come back with the results. All right, guys, so we're back. Interestingly enough, the MX7 is at 48.9 on the ASIC. In Hashwatcher, it says 48. On the dashboard, 48.9. Interesting. So it's so far plus or minus 1. Now, I'm going to leave this set up like this all night because it's midnight and I got to go to work in the morning at 6:30. So I'm going to just let it run all night, and we will continue this video. We'll continue for you guys, will be instantaneously, but for me, I'll continue working on it tomorrow. So we'll be back before you know it to test. I think we're going to go PTM 7950. So, all right. Well, we'll be right back. All right, guys. So it's the next day. Wasn't for you, but for me it is. This is PTM 7950. This stuff is atrocious to put on, just so you know. It sucks. It's not fun, but it's supposed to be one of the best thermal compounds out there. I will clean this up a little bit better so it's not all over the place, but there we go. PTM 7950 from Honeywell. What a pain in the butt to put on. So we'll get this put back together, get it over there, and we'll find out how it does thermally. So hang on just a second, guys. Okay, guys, so we are back. This is the PTM 7950 test. And to be honest, it's kind of disappointing. So obviously with PTM 7950, it's a thermal phase changing material, similar to thermal paste, but not. It comes out as like a clay material, and then once it gets hot, it liquefies. Okay, so kind of a pain in the butt to put on, but it works for certain applications. For this, I don't think it's proper. So immediately it spiked relatively high, let's say 57, as far as what we've been running with the test so far. Once it spiked, then it actually came down. That's probably the change in the phase changing part of it. Okay, so you would notice a spike right away, and then it's settled in at about 50.8 according to the dashboard, and according to Hashwatcher 51, which Hashwatcher naturally kind of rounds up if you look right here. So kind of disappointed. I had high hopes for PTM 7950, but it is what it is. So last up, MX6. We'll see how it compares to MX7 and the rest of them. Now, we'll get this moved back over to the bench, and I'll tear it apart for the maybe the last time, and then we'll figure out what's what when it comes to that. Okay, so hang on just a second. Let's get this moved back over and get this paste applied. Okay, guys, so here we are. We've got our MX7 applied. Just a little P amount on each one should be just fine. I did do probably a little bit more than I should, but that's okay. It's not going to skew the results. The main thing is we want to keep the paste away from that thermal sensor right there. That's the U37. That's the sensor for the ASICs. And yeah, that's all we really need to do is keep it away from there and then make sure we have it evenly applied. So I'm going to get this reassembled and take it back over the table. And then we'll finish up with our final thoughts and results for the MX6. Okay, so hang on just a second, guys. Well, guys, here's our final results. 49.1 on the ASICs. I'm kind of shocked. This is a little bit of a weird one for me. I fully expected the Thermal Grizzly and the PTM 7950 to be awesome. Now, look, let's get this out of the way real fast. This is plus or minus one. You know what I mean? Plus or minus, let's say plus or minus two. Okay. Not a big difference. Okay. But the fact that in this particular controlled environment, 75 degrees, same setup, same heatsink, didn't change anything, just cranked the fans to 100. The fact that MX7 and MX6 are kind of on top here. In fact, MX6 is technically the winner. Uh, I'm kind of stunned. Now, I use Thermal Grizzly on my PC, and it's fantastic. I use PTM 7950 on NVMe's and graphics cards, and it's fantastic. Okay, it works great. No question in my mind that those do not work. Okay, they all work great. I guess the few factors we need to play here is good airflow. We're also working with a device that's using a sensor that's not in the ASIC chips themselves. For example, a CPU or even this particular BM1370 chip does have onboard or like a built-in thermal sensor, but in the NerdQAxe series, as far as the 6.1, this one, the Octax, it's all external. Okay, it's taking a PCB temperature. So you can trick this, but the idea is to not trick it. You want to know. So these aren't actually the ASIC temperatures. These are the PCB area around there. So in theory, you could trick that. You could trick that by packing in thermal paste real heavy, or even getting it on the thermal sensor, the U37 sensor next to the ASICs. So there's a lot to play here. So my final thoughts on this, my final thoughts as far as thermal paste goes, is this. Okay, I believe that we should use what is good and is reliable and we know will last. Okay, PTM 7950, I know it works, but I'm not going to use it because it's a royal pain to put on. Thermal Grizzly, I know it works for a fact. I use it on my PC, a gaming PC, and I know it works, but it's expensive. Okay, one little tube does one for ASIC miner. I can pick up MX series paste or Thermalright paste for pretty cheap, and it works, and I know it works good. So I think the lesson to be learned here is pretty straightforward. Don't let all the hype and stuff get you guys amped up when it comes to thermal paste. Use a reputable brand. For example, MX or Arctic. I've been using Arctic forever. When I built my new PC, I just happened to, the motherboard and CPU combo came with a tube of Thermal Grizzly. It works, okay? But I don't really think you need to go too far into it, okay? Now, would this test be different on possibly like the QX? Yes, because the QX is using the sensors inside of the chip, not a PCB temperature. Okay, so maybe that's something to think about. There is other miners out there that are using the BM1370's onboard chip or onboard thermal sensor on the BM on the chip itself, but not most of the nerd stuff is using an external one. Okay, they have the one for the back that you can trick real easy with a fan, and the one on the front that in theory you could trick it as well. But tricking it is not doing the job. So I guess the only real thing we could take away from this is I want to say we could do a longevity test or how long it lasts, but that's not really the point. Most of these are designed to be serviced within 3 months. Okay, so my opinion, get some MX, get some Arctic MX6 or 7. You'll be just fine. The cost is lower, and you're not spending an ungodly amount of money on thermal paste. I mean, Kryonaut, PTM 7950, Thermalright, Arctic, both brands. I'm probably $80 just in different types of thermal paste, with the Kryonaut being the most expensive. Okay, so it was an interesting test. It was fun to do. It took me a couple of days to put it all together, but I think it was worth it. It was just a lot. It was pretty cool. Okay, it was a lot of fun, and I'm about tired of taking this miner apart. Just so you guys know. Okay, uh, I've had it apart 6 times to do this test, so I want to say a big thank you to AvoidBit for building me this custom stand. Um, it's just awesome. It's so cool. So big thank you to AvoidBit. If you want to check out any of his custom builds for this kind of stuff, there's a link in my description and there's a link in my bio. I do have a coupon code. I believe it's 10%, but hit him up. Builds the AvoidBit, BitTrack racks. He builds the stuff like that. Those over there. Just awesome stuff. Builds great stuff, and it works, and it's awesome. So, anyways, guys, thanks for taking time to watch the video. Appreciate the time. Appreciate you leaving comments and stuff. Let me know down below, what thermal paste do you guys use, and why do you use it? Is it because of hype or cost or whatever? Let me know down in the comments. I really appreciate it. Anyways, guys, thanks for taking time. Peace out.